Good day. Welcome to One-on-One Maths Private Tutors as we look at this topic in trigonometry for pure mathematics 2 and 3 for A-level Cambridge 9709 syllabus. Today we're going to look at the relationship between the secant, cosecant, and cotangent function to the cosine, sine, and tangent. Secant, cosecant, and cotangent are derived from the cosine, sine, and tangent function. We'll also be looking at identities involving the secant, cosecant, and cotan function. But first, we are going to sketch these graphs and see how they are derived from the sine, cosine, and tangent. Prior knowledge of identities such as sine squared theta plus cos squared theta is equal to 1, and tan theta is equal to sine theta over cos theta from the AS content is required or is assumed in this section. We must also know that the identities involving these functions is given in our MF9 formula list provided to us in the examination. Now let's see the relationship. The secant is defined as sec theta is equal to 1 over cos theta. The cosecant theta, cosec theta, or CSC theta is equal to 1 over sine theta. The cotangent, cot theta, is equal to 1 over tan theta. Now let's look at how we can sketch these graphs. We'll start with the sec theta. So for sec theta, we start with the graph of cosine theta. Let's look at this point where cos theta is equal to 1. When cos theta is 1, sec theta is 1 over 1, which will give us 1. So our graph is always 1 at this point. When cos theta is equal to 0, sec theta is 1 over 0, which is undefined. So we have asymptotes at these points. Let's say this is 60 degrees. Cos of 60 is half. When we divide 1 by a half, we get 2. So at these points where cos theta is half, sec theta is 2. So we have these points there. So our graph would come down like this. Asymptotes where cos is 0, division by 0 undefined. And on this side, the negative side of cos theta, we have minus 1. As the value of cos theta, 1 over minus 1 is equal to minus 1. So these points are minus 1. Where it's 0, we have asymptotes. Our asymptotes are here and there. At these points, we have value of cos theta being less than 1. So division by a fraction. Let's say here we have minus half. 1 over minus half will give us minus 2. Here also we have minus half there, and we have our asymptotes. So our graph would come asymptote there, asymptote there. Same this side. Asymptotes there. Asymptote there. Since this is cyclic, we'll always have our graph like that. So in the end, our graph drawn in blue. This is our graph for y is equal to sec theta. So this is our view of our y is equal to sec theta in green with asymptotes at 0.5 pi or at pi over 2, 3 pi over 2 minus pi over 2 minus 3 pi over 2, and so forth. So for the domain of sec theta, x values that are permitted, we can say in set builder notation, x is an element of real numbers. X is not equal to n pi over 2. N is equal to plus or minus 1, 3, 5, and so forth. So we are looking at negative and positive odd numbers of pi over 2. Negative and positive multiples of odd numbers of pi over 2 are not included since these are asymptotes. The graph is undefined at these points, but any other value will do. Issues of domain and range also have to be understood. Range, we are saying what are the possible y values for this graph. Y is an element of real numbers. Y is greater than or equal to 1. Y is less or equal to minus 1. So that's the range. What we mean is all the y values, if we draw a horizontal there, if we draw a horizontal there, our graph is starting from 1 going up. Y is greater or equal to 1. And in between 1 and minus 1, our graph is not defined there. We don't have values for our graph. So starting from minus 1, going down, which is y is less than 1. That's where our graph can be defined. So that's our range. It's excluding minus 1 to 1. Any other real value will give us a result for our graph. Now let's look at cosec theta. Cosec theta is derived from the sine curve. Let's see how we can sketch this. So we have for the cosec theta, we have cosec theta is equal to 1 over sine theta. So we start with the sine curve. This is a sketch of the sine curve. So just like with the sec theta, in areas where sine theta is equal to 0, we have to say 1 over 0, which is undefined. In these areas, we will have asymptotes. So the blue lines will represent asymptotes. When sine is equal to 1, we will have 1 over 1, which is 1. So these points, we have the value 1. Then for areas where, let's choose these areas like 30 degrees here, where sine theta is half. 1 over half will give us 2. So our values there at these points on the graph will be 2. So we have 2 there, 2 there. And the y-axis is asymptote since the value of sine is 0. And these asymptotes are there. So we'll have our graph coming from there, turning at 1, and then going back to the asymptote. So for any value, if we divide by a fraction less than 1, we should have a larger number. That is the same also when we are here at minus 1. Value of cosec theta is minus 1. Here for this value, which is where sine theta is minus half, cosec is minus 2. So these values with cosec being minus 2. Those values, cosec is minus 2. So our graph would come like that. Since these are asymptotes, turn at minus 1 and then come to these asymptotes. Same here with asymptote there. Graph would turn at minus 1 and then come to the asymptote. If we divide by a fraction less than 1, we should always have a bigger negative there. Okay, the same is expected also there. We have this being 2, 1 divided by half, 2. So our graph would come down there, turn at 1, and then go back to the asymptotes. So all this, the graph in blue will be our y is equal to cosec theta. Similar to the sec theta, only a bit of a shift. Now let's look at domain and range. Domain, x is an element of real numbers. Then we exclude the asymptotes. X is not equal to n pi. N is an element of integers. So what are we saying? X is an element of real numbers. Any real numbers can apply except positive and negative multiples of pi. Pi, 2 pi, 3 pi, 4 pi are not included, where n is an element of integers. Minus pi, minus 2 pi, minus 3 pi are not included since they are asymptotes. Also, 0 pi here is not included because it is an asymptote. So any integer multiple of pi is not an element. For the range, it is similar to sec theta. Y should be greater than 1. Y should be less than minus 1. Between 1 and minus 1, we don't have any values for the graph of cosec. Okay? So we can say y is an element of real numbers. Y is greater or equal to 1. Y is less or equal to minus 1. That is the range. Now we look at the cotan function, which is derived from the tan function. Okay, cotan theta is equal to 1 over tan theta. So how do we work this out? When tan is equal to 1, cotan is 1 over 1, which is 1. So these points remain. When tan is equal to minus 1, cotan is equal to 1 over minus 1, which is minus 1. So these points also remain. When tan is 0, 1 over 0 will be undefined. So we have asymptotes there. Asymptotes there whenever tan is 0. When tan is between 0 and 1, let's say at this point, where it is half, cotan is 2. So at this point, cotan is 2.2. That point is 2. All these values below 1, we start from the asymptote, going down up to here. And then for these values, at this point, tan is equal to infinite because the tan graph will approach this tan asymptote but never coincide. So cot theta is equal to 1 over infinite, which is approximately equal to 0. So at this point, the graph comes down to 0. Then it continues again to that point and approaches the cotan asymptote. So it will go on like that and like that. So since the cycle of the tan graph is 180, the cycle of the cotan graph is also 180. So this will start repeating. So we have on that asymptote like that, coming down to 0 at the tan asymptote and coming to minus 1 there, and then continuing to that asymptote. Here we will have also an asymptote there, coming down, and it will approach. Okay, and on this side, we also have the same thing. Asymptote, cross there, asymptote. Make sure these points, 1 there, cross there, and then here asymptote, approach our asymptote and come to our point 2 there, and then our point 1, and then cross at the asymptote of the tan. It will be 0 there, 1, then approach our asymptote there. So this graph in red is our cotan theta, and we have used critical points to sketch it. It will look like this in green here. Now let's look at domain and range. Domain, what x values are permissible? X is an element of real numbers. X is not equal to n pi, where n is an element of integers. Okay, so we are excluding all these values. Pi is an asymptote, 2 pi is an asymptote, minus pi is an asymptote, minus 2 pi is an asymptote. All these multiples of pi by integers, positive or negative, are not included in the domain. For the range, any value, y is an element of real numbers. Any real number is applicable. Now that we've managed to sketch the graphs, let's look at the questions. Find the exact value of sec pi over 6. Sec pi over 6 is equal to 1 over cos pi over 6. Pi over 6 is 30 degrees. Cos of 30 is root 3 over 2. This will give us 1 times 2 over root 3. We multiply by the inverse if we are dividing by a fraction, which will give us 2 over root 3. We can multiply by root 3 over root 3, and we get 2 root 3 over 3. We rationalize our denominator. So this is our answer. B, describe the domain of the function f of x is equal to 1 plus sec x. In AS, we did transformation of graphs, of sine and cosine graphs. That knowledge is assumed in this section. So what we're going to do, we're going to carry out this transformation. We have sec x, which is this graph in green. And when we say f of x is 1 plus sec x, we are transforming it. So 1 plus sec x is a translation of sec x along the y-axis by 1. So we are going to move this graph up by 1 unit along the y-axis. So this point here will move from 1 to 2. So we'll have this coming up there. This also will move up there. This also will move up there. So we have our graph. This will move there. Remember, we must keep our asymptotes there. Just move it up along the y-axis by 1. So from minus 1 by 1, it goes to 0. And it also does the same thing there. Okay, so now we have our graph of y is equal to 1 plus sec x. Describe the domain of the function. So it's x values. What we are excluding are the asymptotes. So we can say domain x is an element of real numbers. X is not equal to n pi over 2. N is equal to 1, 3, 5, and so forth. So we are looking at odd multiples of pi over 2 are excluded. Okay, so x is an element of real numbers, but not odd multiples of pi over 2. So this should also be in the negative. So we should say n is equal to plus or minus 1, 3, 5, and so forth. Describe the range of f of x is equal to 1 plus sec x. Range will be y greater or equal to 2, which will also include 2. Y is less than or equal to 0. Y is an element of real numbers. We don't have any values for our graph between 0 and 2. Let's now see how we can formulate trig identities involving sec, cosec, and cotan. We know the identity sine squared theta plus cos squared theta is equal to 1. If we divide both sides by cos squared theta, this will come up to sine squared theta over cos squared theta plus cos squared theta of cos squared theta is equal to 1 over cos squared theta. Now this is the same as saying sine theta over cos theta squared. These two will cancel out, plus 1 is equal to 1 over cos theta squared. This will come up to You know, sine theta over cos theta is tan theta. So tan theta squared plus 1 is equal to 1 over cos theta is sec theta. So sec theta squared. So now what we have is tan squared theta plus 1 is equal to sec squared theta. That is our first identity. Another identity can be formed from the same. Sine squared theta plus cos squared theta is equal to 1. Here we divided by cos squared theta, we can divide by sine squared theta over sine squared theta, dividing both sides by sine squared theta. So we have sine squared theta over sine squared theta plus cos squared theta over sine squared theta, which is 1 over sine squared theta. This will cancel out and we have 1 plus cos theta over sine theta squared is equal to 1 over sine theta squared. This will be 1 plus cos theta over sine theta is 1 over tan theta. 1 over tan theta squared is equal to 1 over sine is equal to cosec theta. This comes up to 1 plus 1 over tan is cotan. Cot theta squared is equal to cosec theta squared. We have 1 plus cot squared theta is equal to cosec squared theta. That's our other identity. So now we have these two identities involving sec theta, cotan theta, and cosec theta. Let's look at a question. Solve the equation tan x plus sec squared x is equal to 3. So we can say tan x plus sec squared x. We can see sec squared x is 1 plus tan squared x plus 1 plus tan squared x is equal to 3. We take this 3 to the other side, form a quadratic equation, and rearrange it. We have tan squared x plus tan x minus 2 is equal to 0. Now for easier viewing, I usually say let tan x be equal to t, tan squared x be equal to t squared. Now we can say t squared plus t minus 2 is equal to 0. When I factorize this, t squared plus 2t minus t minus 2 is equal to 0. T factor of t plus 2 minus 1 factor of t plus 2 is equal to 0. Factor out t plus 2, t plus 2, t minus 1 is equal to 0. So we can say t is equal to minus 2 or t is equal to 1. When I go back, t is tan x. So we can say tan x is equal to minus 2 or tan x is equal to 1. Now we use our cast diagram. For tan x is equal to minus 2, we can say tan x ref is equal to 2. X ref is equal to, which is lift tan 2 will give us 63.43 as our reference angle here. And our question requires us to find from minus 180 to 180. We are looking at areas where tan is negative, fourth quadrant and the second quadrant. So here it's minus 63.43. There it's 180 minus 63.43. So we can say x is equal to minus 63.43 If we calculate that, 180 minus 63.43, get 116.57. Let's look at when tan x is equal to 1. X is equal to arctan 1. X is equal to 45. So we take our cast diagram, 45 there. Where else is 10 positive? Here, 45. So x is equal to 45. X is equal to 180 plus 45 won't work. So it will be, so we are looking at this angle. If this is a straight line, we can say 45 minus 180, which will give us minus 135. Or we can start from here, going in the negative. Up to dates minus 90. From minus 90, we go minus 45. So it's minus 90 minus 45, which is also equal to minus 135. So x is equal to minus 135. Our solution set is x is equal to minus 63.43, 116.57 minus 135 and 45. And we can see they are all between minus 180 and 180 as our question requires. Thank you.